Hi, and welcome to Healthcare Simplified with Manvir Victor. I'm your host, and on this series of podcasts and vodcasts that we are calling it, you will be able to see and find out a little bit about healthcare simplified. We're not going to use huge words. We're going to make it as simple as possible because we want the tools and the information to be in your hands so that you can make better decisions about your healthcare outcomes, right? Right here on Vital Signs, your hub to better health. So today with me in the studios right here for our very first vodcast, I am so glad to have Dr. Rubben Chinnathambi. Hi, how are you, Doctor?
Hi, Manvir. I'm good. How are you?
Good. So you're popularly known as Dr. Rubben, and you are a cellular biotech expert, right? Now, these are huge words. So let's cut it down. Let's make it simple. Like Denzel Washington said in the movie Philadelphia, explain it to me like I'm a 4-year-old, please. So tell me, what is cellular biotech?
All right, Manvir. Firstly, thank you for having me on your podcast. It's truly a pleasure to be here. And I'm so glad that finally someone has actually decided to make a message clearer so that everybody understands what is being said. I think this is something that is really lacking, especially in the industry that we are in.
Okay.
So cellular biotech. Now, the moment people hear cellular biotech, it sounds extremely scientific, extremely fancy, and I'm going to stay away from this because it sounds really expensive as well.
Right.
So it's not something new, Manvir. I mean, cellular biotechnology has been around for, I would say, more than 30 years, where people have actually indulged and done a lot of work to understand what it's all about. But in short, cellular biotechnology is basically us harnessing the resources and the technology from cellular products. So when I say cellular products, they could be anything that is derived from live cells.
Live cells.
Live cells. They could be products that are not alive but derived from these cells.
Okay.
So it could be growth factors. We'll get to that later.
Right.
Or it could be any technology that is applying something that is related to cells.
Okay.
So in short, Manvir, we are all made out of something, right?
Yes.
So we are human beings. Our body is complex, but we are made out of something.
Yeah.
So what is that something?
Right.
So people will say things like DNA. You share DNA, right?
Right.
RNA.
Right.
So those are really very, very, they are very comprehensive stuff in the body.
Right.
But they all form something called cells.
Cells, okay.
And those cells
Right.
are what forms all of the tissues, all
Right.
of the organs,
Right.
which develops the human body as a whole.
Okay, that's a good explanation.
Yeah.
Very simple there.
So cellular technology is focusing on the cells.
Okay.
Where else a lot of forms of medicine today focuses on the superficial aspects, which
Okay.
is disease, side effects.
Right.
But no one actually focuses on the root cause
Okay.
or the real possibility of all of these problems,
Right.
which lies down there.
Okay,
So
absolutely.
that's the field that we are in.
So since you mentioned the word from cellular, we've got cells, right? And today, when you use the word cell, everybody straight away understands it as stem cells. So stem cells, am I right, is part of cellular biotechnology?
So it is.
Yes.
So part of this entire ecosystem has been revolving a lot around stem cells.
Right.
Now, the reason why everyone goes immediately to stem cells is because it's been around for a longer time compared to the rest of the technology involved in this field.
Sure.
And I think there has been a lot of information
Right.
or a lot of marketing that has been done
Right.
by many companies from all around the world,
Right.
which revolves around stem cells.
Yes.
So that's the first go-to.
Oh, absolutely, yeah.
And I kid you not, Manvir. I mean, you see stem cells practically on everything right now.
Absolutely, which is one of my questions later. Yeah, yeah.
So yeah, but yes, to answer your question, it is part of this ecosystem.
Right.
And it's actually a very big part with a lot of work being done, work that has been done and work that is being done
Right.
to refine this technology and use it for potential therapies.
Okay, so if I get you correctly, this is an ongoing process of learning about cells, how it works in us, what we can do to enhance it, right? So when we come to stem cells, and part of my research into doing this podcast with you, I find that there's so much ambiguity about the word stem cells because it's so vast. It's pretty confusing because you have stem cells that come from cellular biotech and all this, as low as 50 ringgit, which is about 12 USD or something like that, right up to maybe 50, 70, 100,000 ringgit, which is 30, 40,000 US dollars. So there's this huge variety of this. And to me, as a patient advocate who's learning about this, I think people are taking advantage of the word and sticking it on a box and they're selling it. And I've got a lot of friends who come up to me and say, "Oh, I'm taking stem cell. I bought it over the pharmacy counter. I bought it here. I bought it there," and they're getting it on shopping. I know you can get it on Lazada and stuff like that. So, what exactly is this difference between the 50 ringgit or the 10 US dollar to the 30,000 US dollar range? What's the difference? Where is the real thing that we know we're buying in? It's good for us because we're putting these things in our body.
Yeah.
How good is this and which one is reliable?
Okay. So I think the first part that I will need to highlight, Manvir, is the fact that we need to understand what are stem cells.
Okay.
What kind of stem cells are we talking about?
Sure.
So if you are mentioning stem cells, then they need to be cells. So these are live cells, correct?
Absolutely.
Unfortunately, live cells, just like any other cell in the body, they have a lifespan. So they can survive for a certain period of time and in a certain environment.
Okay.
All right?
Right.
Meaning if you do not keep them in that environment,
Right.
they're going to die.
Yeah.
They're alive.
Okay.
It's just like any cell in our body.
Sure.
If there is, say, you have an impact or trauma,
Yeah.
some cells in that area are going to die. So, unfortunately, I think the blame is on everyone. So it's
Okay.
not just the medical professionals, it's not just the medical fraternity, it's also the public because we have not been asking the questions that we should be asking.
Absolutely, yes.
So we are being gullible. So anything that we see, like what you mentioned, online.
Yes.
I mean, you're not going to get something which you have not verified, you don't know the authenticity,
Yeah.
and put it into your body. Okay? So let's get back to that. Stem cells are in all living organisms.
Everything.
Everything. Meaning,
Right.
not just human beings.
Yes.
You're going to get stem cells in animals.
Plants.
You're going to get stem cells in plants, correct?
Yeah.
So, what kind of stem cell are we supposed to use in the medical industry? All right, supposedly. Let's get a bit scientific, but
Right.
very something easy to understand. Now, when we are talking about the human body,
Right.
anything that we do has to be compatible to the body.
Absolutely. Yep. True. Yeah.
Correct?
Yeah.
So if you are taking, example, blood, when you're taking blood from a donor, say you need to top up your blood, right?
Right.
Would you consider taking blood from a monkey?
No.
Correct, because you're putting something into your body
Yeah.
that your body needs to understand. Your
Absolutely.
body needs to accept.
Yes.
So when it comes to stem cells, it is the same thing.
Yeah.
Now, there are many groups in this industry which are focusing on animal and plant stem cells.
Okay.
And if you're consuming these products,
Right.
and I'm not going to say anything negative, it's not my place to say that, but at least you know that it's going to go through your digestive tract.
Right.
And it's going to, you're going to
Yeah.
absorb what you need and the rest
Sure.
is going to come out.
Right.
But if you're doing a medical procedure using products like this, and probably not so much in Malaysia, but I've read a lot about, I've spoken to a lot of doctors from other countries, and
Absolutely.
it can be pretty large in certain countries, then you have to consider the fact that your body does not accept this form of stem cells. It is
Okay.
going to reject them.
Yes.
And that's dangerous. That's
Absolutely.
where you create a lot of problems.
Yeah.
So you need to understand the source. So now, coming to the source, even if you talk about stem cells coming from the human being, all right? Say it's coming from a part of your body.
Right.
Say it's coming from your blood, or it's coming from your fat, or it's coming from your bone marrow.
Right.
Right? How you use these cells are very important. So if you're going to consume something which is of stem cell origin,
Right.
once again, going through your digestive tract, you have got a lot of acid in your stomach.
Absolutely.
It's going to destroy everything.
Right.
So the treatment has become more focused. People from all around the world, the research that they are doing are focused on using stem cells,
Right.
but it will be more targeted. So it could be directly applied to an organ. For instance, directly applied into your brain,
Yes.
or into your heart,
Okay.
or into your pancreas for
Okay.
that matter. Or they would have found a way to send these cells to a particular point of your body. So like a target.
Sure.
So maybe they add some signals and then they send it via your blood to a particular point in your body.
Yeah.
So there are so much of technical aspects to a proper stem cell procedure.
Okay.
All right? Scientifically as well as medically.
Absolutely.
Now, when you're getting something which is of a plant or animal origin, probably you're getting it from a, I don't know, a mouse or a rabbit for that matter. I mean, how much is that going to cost you? So that's where you get your 50 ringgit and your 100
I
ringgit.
see.
But if you're talking about going through scientific procedures
Right.
to harness live cells from the body,
Body.
and to use them back as a form of treatment,
Right.
then there are many processes involved,
Okay.
including processes such as screening.
Screening. Okay.
You need to make sure that those cells are safe. You don't want them to have any contamination.
Right.
You don't want them to have any malformation
Right.
or genetic mutation. You don't want them to be dangerous.
Yes.
So that screening processes can be very costly.
Right.
So if you don't cut corners and you're doing everything correctly,
Right.
there is going to be a price to pay.
Of course.
So you're going to see prices which are a little bit higher.
Right.
But of course, that being said, my understanding of this industry is that it is still in an affordable range. So when
Okay.
you see something which is probably too high, ask.
Ask the
why?
question, yeah,
Yes. Why is it so high? What are you doing?
Right.
What is special about what you're doing?
Yeah.
For all you know, it could be probably just a marketing gimmick.
Absolutely. Yes.
Correct. I guess, Manvir, in this area, there still needs to be a lot of awareness
Sure.
and a lot of education.
Right.
People really need to know what is available.
Yeah.
What are the options that you have and how do you utilize them?
Sure.
So that's the problem here.
So, correct me if I'm wrong right now. So, there's this vast array of stem cells out there, right? And we're trying to nail it down to what is suitable for me, as opposed to the next person and the next person and the next person. So, we need to know what are the right questions to ask. So, based on your explanation right now, whether you've got a stem cell from a mouse or a plant or a rabbit or a cat or whatever it is, by and large, are the stem cells that we buy on some of these online shopping markets, are they to be trusted? Because you were earlier alluding to the lifespan. Now, lifespan, but you are buying something, you go to one of those carts, you put your product in, and then they send it to you a week later. Now, how safe is these things that we're putting into our body? Isn't that lifespan that we are talking about? Is it been safely produced all the way through the production before it reaches there? And would you believe something? Would you yourself buy something of one of these
All right.
markets?
That's a good question. So personally, I would not.
Okay.
Maybe you can say that I'm being biased because I am a medical doctor, so I'm a little bit more careful.
Right.
But that being said, again, on a personal level, I have actually had people close to me
Right.
purchase, you name it, from these online platforms.
Yes.
And I've actually seen how bad things can get because we have actually done some works on people who have been feeling ill after consuming products like this. And I kid you not, Manvir, the effect on the body can be very detrimental.
Wow.
So you can even have changes in even up to your hormone levels for that matter.
Really?
Yes, consuming the wrong stuff which you have no idea about. So this is where, once again, if you're going to put something into your body for whatever reason, please put in the initiative and take the time to understand what it is all about.
Okay.
Now, talking about, you mentioned about lifespan. Now, from a scientific point of view,
Right.
when because we do a lot of work, a lot of research work, and from that point of view, when you are using something which involves live cells,
Absolutely.
usually the lifespan is really, really short. So
Okay.
you're talking about hours,
Hours.
if not just a few days. Yeah,
Okay.
that's it. Yeah. So if you're talking about, I give you an example. Say there's been a lot of work which has been done on sports injuries
Sure.
using cellular biotechnology.
Right.
And these procedures are done very quickly, meaning
Okay.
the moment the product is ready,
Right.
the administration is done on the
Immediate.
same day. Yeah,
Immediately.
immediately. Yes.
Okay.
In fact, some of the certain countries have actually adopted what we call bedside
Bedside.
preparation.
Okay.
So it's actually done in the medical setting itself.
Okay.
And applied immediately. That's how fast it needs to be done. Because
Okay.
they're live cells, right?
Sure.
And if you're talking about the byproducts or the what we call non-live products, which
Yeah.
is also cellular based, then maybe yes, they have a slightly longer lifespan.
Right.
But once again, you need to understand what they are.
Yeah.
And again, we don't add preservatives or chemical compounds because then it affects the way these products work.
Right.
So you're not looking at anything beyond, say, 6 months or a year.
Right.
But all of a sudden, you get products that can last for 3 years or
3
5 years. And,
Okay.
and you start questioning what's inside there.
Right.
Yeah.
That possibly means that there's a mix of something inside to
Yeah.
keep it preserved.
Yeah.
So,
And number one, they can't be live cells.
Right.
And number two, even if you're using cellular byproducts, it is fairly impossible to use oral administration at this point of time. Of course, maybe in the future, when there's more research,
Right.
then maybe. But at this point of time, I don't think those have got anything to do with cellular technology.
Right.
This is my view.
So just to check on once again, so when you buy a product, let's say it's not a live cell, but it's got a shelf life, let's say like you said 6 months, but that's in a perfect situation, which means that it needs to be in an optimum environment, optimum temperature, all these things.
Correct.
So you buy something, it's stuck in some warehouse, you don't know whether the warehouse is air conditioned, it is sent through whatever your courier company is, you don't know the process that it is moved to reach you at your home.
Exactly.
So that environment may diminish the potency of that medication,
Correct,
right?
of whatever is inside that bottle, for
Absolutely, yeah.
instance. And to add on to what you said, I mean, when you're dealing with live cells, everything has to be cold chain because
Okay.
they're sensitive to temperature.
Right.
They're even sensitive to movement, Manvir.
I think.
Meaning, if you shake them,
Right.
then the cells are actually going to be affected, and this has been established. I mean, people have actually checked on it. So
Oh, wow.
that's how complex the process is. It's not
Right.
as simple as putting it into a bottle and throwing it on the shelf.
Okay, we're going to take a quick break and then come back with more. But I mean, before we leave for a break, I'm just going to tell you that. So if you happen to buy something on an online market or something like that, this entire process has probably diminished that product already. It has probably been shaken, it's probably been in heat, it's probably been in colder weather, whatever it is. But the efficacy of that particular medication may not work. So we're going to be back with Dr. Rubben right after this quick break. Okay, we're back right here on Healthcare Simplified with Manvir Victor, and I've got my guest, Dr. Rubben. Dr. Rubben, we are unpacking, if you may, cellular biotech. So, part of that is this huge word called exosomes, which everybody happens to be raving about. Break it down for me, like a 4-year-old. What is exosomes?
Fantastic. So this is something that has taken the entire industry by surprise.
Okay.
So like I mentioned earlier, Manvir, for things like stem cells, there has been a lot of work over the last 20, 30 years. Exosomes is something that has recently, it has come out. It is a byproduct of this cellular technology.
Okay.
So they're not live cells. However, there is a lot of potential for these exosomes because what they really are is, Manvir, they are a form of protein that serves as a signal.
It's a form of protein serves as a signal.
Signal.
Okay.
So the right word is signal.
Right.
Now, let me explain how stem cells works so
Okay.
that we'll get to exosomes after that. Now, stem cells are live cells that are used for any therapy.
Okay.
What actually happens in the body is they talk.
Okay.
As
Yeah.
simple as that.
Right.
The cells go into your body, they are alive, they talk with whom? With your cells.
With my cells. Okay.
Correct. So there's communication. Now, when the stem cells are talking to your cells, if say you have some problems in your body,
Right.
are going to tell these new stem cells, they're going to complain. Look, I have so many problems.
So my body is telling the stem cells.
They're
okay.
complaining to the
Right.
new cells that are
Right.
coming in. Now, these new cells, of course, with technology and with the enhancement that we have, they should be more capable than what your body cells are able to do.
Okay.
All right? Especially if the source is correct. So
Okay.
you're getting cells from, say, I give you an example, say it's coming from a younger source, such as an umbilical cord, for instance, example. So the cells will definitely be more energetic, more excited compared to what's already in your body.
Okay.
Because your cells have undergone aging. We
Of
all
course.
age, correct?
Yes, right.
So as they complain, these new cells that go into your body are going to try to help
Okay.
your cells
Right.
to overcome all of these problems, these complaints.
Right.
For instance, if your cell is saying, I mean, you know what inflammation is, right?
Yes.
Inflammation is basically you have a problem in your body tries to overcome that problem.
Right.
It forms something called inflammation.
Sure.
Now, say the cells are going to try to help you with that inflammation.
Right.
What they do is they send out signals,
Okay.
signals that will trigger particular responses in your body
Okay.
to do a particular job.
So the new cells are talking to the old cells, and
They're sending out signals.
Signals.
Yes.
Right. Okay.
So now these signals will go to your cells
Right.
and tell them, look, you need to do this and this
Right.
to control the inflammation.
Right.
So then your body responds.
Okay.
So that's the process.
Yes.
It is all talking.
Yes.
All right?
Right.
Now, exosomes is a form of that signal.
Okay.
So when the cells are talking, they're sending out a variety of signals. You're not talking about one or two. You're talking about probably 1 million signals.
Sure. Of
right?
course. Yeah.
For every communication. And you can imagine all the cells in your body communicating. That's a huge
Sure, yeah.
body in there, right?
Yeah, yeah.
So exosomes is a kind of that signal. Now, the beauty about exosomes is it is able to tell your cells to do particular functions.
Okay.
All right?
Right.
Which means, like I said just now, it could be a function to reduce inflammation,
Okay.
or it could be a function to repair the heart,
Right.
or it could be a function to repair the pancreas.
Right.
Okay? Now, using that concept, that
Right.
technology,
Yeah.
when we harness the exosomes
Right.
and we are able to characterize them, or in other words, we are able to control what they do,
Right.
then by re-administering the exosomes,
Right.
you are able to trigger that particular form of communication
Right.
between the new cells
Right.
and your cells.
Okay.
Okay?
Right.
So the problem with just using stem cell technology alone, I think this is something that everyone will agree from around the world, is that we are unable to control exactly what they do.
Okay.
Meaning it all depends on that communication.
Right.
If your body says that there's a problem, then they try to repair the problem.
Okay.
What if your body says that there's no problem? I give you an example. Say you have a heart attack,
Right.
and a chunk of your heart the tissue has died. The cells are dead.
Yeah. Yeah.
And initially, when you get the heart attack, your body tries to repair. Unfortunately, it is unable to repair. 3 years down the road, your body says, look, I'm used to it. Let it be.
Okay.
So the dead tissue is dead.
Yeah. Right.
When you put new cells into the body,
Right.
will your body say that there is a problem with the heart? No.
No.
It's been 3 years.
Yeah.
It's not a problem anymore.
Right.
So you go and try to rectify the other problems.
Right.
So your heart tissue is never going to
Fix.
be fixed. But if I can take an exosome
Right.
and trigger
Right.
that particular function
Right.
and put it back into your body, then I give you something like live cells.
Right.
Then the live cells are going to listen to the exosome because the signal is there. So they are
I
going
see.
to go directly to
the-
whichever point we have triggered them to go to,
Right.
and stimulate a response.
I see. So there's new cells, there's old cells, and there's this communication mechanism that directs them to which
What they're
part
supposed
to
to
go.
do. Yeah. So that is exosomes. Now, the theory behind it is amazing
Okay.
because it gives us access to, I mean, the scientific world is going crazy about this, right?
Right.
However, in order to characterize the exosomes, to tell them what to do,
Yeah.
now that is manipulation.
Sure. Of
And
course.
manipulation needs to be done very carefully. Because,
Right.
again, I'm talking about this from a scientific point of view.
Right.
If you do not tell them what to do correctly,
Right.
then they're going to do something which is not correct.
And the wrong part of your body that you probably don't need.
And this is what we are all afraid of.
Right.
Because if the exosomes do something or they stimulate a response that is not what your body needs,
Right.
then you're practically doing something that could cause harm rather than do good.
Absolutely, yes.
Correct. So then we start getting worried about, what if you are creating inflammation at a point that doesn't require inflammation?
Okay.
What if there is a possibility for maybe even things like cancer to come out of the picture? Yeah. So we are afraid. So that is why the exosome technology, of course, there's a lot of work being done
Right.
on this field. And it is still not reached a point where I've been in this line for about 11 years, Manvir, and I'm
Right.
still being very careful when I speak about things like exosomes.
Okay. So you mentioned the word theory. In theory. So this is not in practice that we can control the exosome, that communication period. So why are people taking exosomes now? Because I've had offers of some people come and say, I think you should take exosomes, you should do this thing. So why are they selling me this middle part here? And then you're saying it's theory. We haven't been able to, in practice, control, have that conversation with the right place, direct it. But people are selling this middle part here.
Unfortunately, that is I would say, the sad reality of the industry as a whole. Exosomes are really good. There is so much of potential. In fact, I've been traveling to many parts of the world to understand more about exosomes, and the work is amazing.
Right.
Some parts have been slightly more established. For instance, when you're talking about skin or dermatology, there's a lot of work being done there.
Okay.
Wound healing using exosomes.
Okay.
There's a lot of work being done there. But I have heard, just like you, Manvir, I've been hearing people saying exosomes are the cure for stroke, are the cure for kidney failure. And honestly, I've not seen enough data to back things like this up.
Right.
I've not seen. All right?
Yeah.
And unfortunately, exactly what you mentioned.
Yeah.
People are claiming.
Absolutely.
So this is where we as consumers need to ask,
The right questions.
what evidence do you have that it's going to repair my kidney?
Right.
Do you have enough work that has been done
Right.
on the exosomes
Right.
for it to actually stimulate such a response?
Absolutely. Yes.
And if there isn't, then please be very careful.
Right.
Because first of all, even to identify whether it is exosomes or not is not an easy task.
Okay.
On top of that, this is coming in probably, like you said, a bottle or some nice package.
Yeah.
So you got to be very careful.
So do these exosomes, they come from a stem cell, or where do they derive from? Where's the origin of this thing?
So once again, stem cell is only a portion
Okay.
of cellular biotechnology. So exosomes may come from stem cells.
Okay.
They could come from other cells as well.
Oh, it can come from
For
us.
instance, we could use immune cells.
Okay.
We have things like T cells, you know what
Yeah,
T cells in
T
the
cells,
body, NK, natural killer cells, these are all in our body.
Yeah.
Exosomes can be derived from those cells as well.
Okay.
Now, work is being done to compare.
All right.
So if I'm taking exosomes from this particular part, what is the efficacy?
Sure.
If I'm taking exosomes from another, like immune cell, for instance, what is the efficacy?
Right.
What is the markers or the characterization on this particular exosomes and what I can use them for?
Right.
Like there's been a lot of work in Asia.
Right.
It's not in US. It's in Asia, where they've actually used immune cell derived exosomes.
Okay.
And they have actually tried to tackle cancer. There's a lot of work being done on that.
I like the word that try. They tried,
Yeah,
you know.
they're trying. So it is not established yet,
Okay.
but it's being tested.
Yes.
So of course, probably a year or two from now, they may have more concrete evidence. But until that is available, you got to be very careful.
Absolutely.
It's
and,
new, yeah.
and so there are people who've come up to me and said, I've got 50 million shots, or 50 million exosomes, and I feel great. You know, is this a placebo? Is this a mental thing? Because you're saying it's protein.
Yeah. So I would not say it's completely placebo.
Okay.
You will have some reaction if you're injecting real exosomes into the body. It's just that you don't know what the reaction is. So that reaction could make you feel better.
Okay.
But at the same time, it could be something you don't need.
I see.
So it's not fully placebo. I mean, I've spoken to a lot of these people who have undergone this kind of procedures. And yes, some of them actually do have improvements in certain parts of whatever they're going through. But you don't know the rest of the story.
You don't, yeah. So you,
Yeah.
I mean, because it injects into your bloodstream, it goes everywhere.
Correct.
And there's so many conversations happening, like you said, but we're not directing the conversation to fix that particular problem.
Correct.
Right?
Now, let's, if you don't mind, Manvir, I would like to touch something that has recently been done, which was very amazing for the scientific world as a whole. So China recently has done some amazing work using a combination of cellular technology, I mean stem cells,
Right.
together with a little bit of this signaling technology.
A little bit of it.
Signaling, right?
Okay.
Exosomes and things like that, where they've actually been able to reverse diabetes successfully.
Type 2.
Type 2.
Okay.
Successfully. This patient was on insulin.
So it's one patient they've done this
Patient,
with. Okay.
One patient on insulin, and the patient has been insulin free for 39 months.
Oh,
Okay.
right.
Now, of course, it is one patient.
One patient. Yeah.
So I'm very sure that they are currently doing a larger scale study, sorry. But the fact that they have kept the patient diabetes free
39
for
months.
39 months
Right.
is amazing.
So they have managed to, with a mixture of cellular biotech, stem cells, and exosomes,
Exosomes, yeah.
target the pancreas. They've targeted the pancreas and they've revived it. They've regenerated it.
Correct. So they have actually they've given a second chance to the pancreas to start functioning again. At the same time,
Right.
they have also helped your body. You've heard of insulin resistance, right?
Sure, yes,
So they've
yeah.
actually helped the body to reduce that resistance, meaning
Right.
your body actually utilizes the insulin produced better.
Right.
So they have actually done it. Now, one of the biggest parts that is being heavily investigated in cellular is something called iPSCs, induced pluripotent stem cells.
In use?
Induced pluripotent stem cells.
Okay.
You will be hearing about this a lot
Right.
over the next few years.
Okay.
Because after exosomes, this is going to be the next big thing.
The next big thing.
This is where you are able to use this signaling technology,
Okay.
combine it with stem cells,
Right.
and create a cell that does a particular function.
Oh, you can create a cell now. Wow.
They're actually doing this, and a lot of work is being done. Once again, the two biggest areas which are doing work on cellular is, of course, US being number one, and second is actually Asia.
Oh,
So
fantastic.
countries like China,
Right.
Taiwan, Korea, Japan, they're heavy on R&D.
Okay.
So there's a lot of work being done, right?
Okay.
Now, when this technology is available, and if it comes soon, I hope,
Right.
then we will actually be able to tackle a lot of problems precisely.
Precisely. Okay.
Yeah. But for the moment of time, you need to be very careful when somebody makes claims that things like exosomes,
Yes, absolutely.
healing something in your body,
Yeah.
ask them how.
So today we've learned that what exosomes are, what stem cells are, in a very, very basic. This is a very basic conversation. But I think what sparked this was the fact that so many people are taking it. And, everyone will ask you for 1,000 opinions on whether to buy an Apple phone or a Samsung. But, something that they're getting on Lazada, yes, just eat it. It just, blows my mind that people would do that to their own bodies. So we've unpacked that a little bit. But let's take a step back from stem cells and cellular biotech. But let's talk about you. So you're the founder of Cell 101. And what's Cell 101 right here in Malaysia? And what are you guys doing?
Okay. So Cell 101 is something that I founded about 3 years ago
Right.
because I realized that there was a gap in the cellular biotech industry.
Right.
So for the last 11 years of me being in this industry, once again, I've seen the good and the bad.
Okay.
So I've seen potential of this form of technology and how it actually is able to help solve a lot of problems.
Right.
At the same time, I've seen how bad it can be when it's not utilized correctly.
Okay.
So because of that, we decided to open Cell 101, and 101 means basics.
Basics. Okay.
So the idea of this company is to create a platform where people, everyone, gets to understand what this technology is all about.
Right.
So to share with you what our latest achievements, of course, we have been doing a lot of research. We've been working with quite a number of universities, both locally and abroad. At the same time, we are in the midst of building a facility that will give access to people to come and see what a cell looks like.
Oh, really?
Yes.
Okay.
What an exosome looks like.
Oh.
Yes. What or how it works. Maybe we can show you how it actually works, not inside the body, but outside. Maybe in
Of course,
in the
of
lab.
course. Yeah.
At least people will understand.
Right.
This is what's happening.
Absolutely.
So Cell 101's goal is to create, it's two things. One is, of course, for general public, where they're able to witness and see things.
Right.
If they decide to embark on a journey involving cellular technology, then understanding the basics is key.
Right.
The second part of Cell 101 is basically to train medical professionals people in the fraternity
Sure.
on how to use this form of technology in what we are practicing right now.
Right.
So there needs to be someone who sets the benchmark.
Sure.
Now, internationally, there are a few associations which have been quite active.
Right.
We have tried to get in touch with them, and we are trying to apply the same concept here in Malaysia.
Right.
Of course, Southeast Asia still has a little bit of time to really mature.
Sure.
But we are moving at a very rapid pace.
Okay.
And I think Malaysia is actually leading because I've spoken to some people in our Ministry of Health as well, and they're doing a lot of work, a lot of understanding. They've put the right people to actually understand this industry.
Right.
We do have our local associations as well, and I believe that Malaysia has the potential. If this is done correctly, we can actually benchmark
Right.
this technology
Right.
in this region.
Oh, wow.
Yeah, so Cell 101 is hoping to be part of that ecosystem.
Okay.
That's what.
So very interestingly, you said there's a lab being set up where general public and obviously some people can come over there and look at this whole facility. I mean the entire process to be able to understand it better. I'm putting my hand up. I will be there.
I will put you on the first list then.
Yes, but when is this facility going to be ready?
Yeah, so we're looking at about February or March next year.
Okay.
But we'll keep you updated.
Sure.
So that's very
absolutely.
soon. It's just a couple of months. I mean, a few months away. Yeah.
Yeah, obviously. So it's very interesting that there's so much of science in this, and it's all to make people feel better, have better outcomes. And it's a bit frustrating for me to see sometimes that people are just using products and services without understanding them. And this is big money.
Yeah.
This is a huge amount of money that people are injecting themselves with. And I'm afraid because, if you take a pill, when you stop taking a pill, over the next 72 hours, the efficacy of that goes down. But, you inject yourself with something, it's there with you.
Yeah.
You can't get rid of it.
Correct.
It
So you
doesn't
gotta
go
be
into
very
your
careful,
digestive tract, all that. So it's important for people to learn that. So is there one message that you would say, or one pertinent question that people should be asking if someone comes and offers them, whether it's an exosome or a cellular biotech product? What's that one question that people should always ask them,
Okay. I would not say one question, Manvir. You got to ask a lot of questions.
Okay,
but I
absolutely.
think the bottom line is to understand, number one, the source.
Sure.
Where do these cells or these exosomes come
from?
Number two, what are their functions? What are they going to do?
Right.
Okay, if you're taking an exosome, what is it going to do in your body? You have to ask. Check for credentials, credibility.
Okay.
Who is the person talking to you?
Right.
Does the person have experience?
Right.
Is it a medical practitioner or is it someone who is just, selling snake oil, for instance?
Right.
So you got to be careful. And then you also need to understand how is it going to be applied?
Right.
What is the process?
Yeah.
What are the guidelines? What are the protocols?
Right.
And what are the risks that come with this therapy? Every treatment or every what we call medicine for that matter has some risk.
Yeah.
Even taking a Panadol has risks.
Absolutely.
Correct?
Yes, it
we know
does.
that it has an effect on the liver.
Right.
But it's not wrong, but at least we are aware about it.
Yeah.
So we have to ask
Right.
all of these right questions
Yeah.
to the person who is offering this therapy to you and then make a decision. Don't just get one input, ask a few people.
Sure.
Speak to people who are in the industry, speak to friends,
Right.
get your homework done,
Yeah.
and then decide whether you want to embark or not. Yeah.
Fantastic. Well, thank you very much for your time. Thank you for
having
coming
me, Manvir.
on this podcast with us. Well, that's our first episode. We've just wrapped it up. Healthcare Simplified with Manvir Victor. We have unpacked, I hope, cellular biotech enough for you guys to be able to ask the right questions before you put something in your body. Okay, we're going to be back once again with another episode soon. But thank you very much for being a part of Vital Science, your hub to better health. Thank you.